This is a technology preview of EMC shown at VMworld 2011, showing merging compute and storage, and also Project Lightning with VM integration. So what you can see here is that we've got a standard set of ESX hosts in a standard cluster, one of them that's running a Hadoop-style bandwidth-constrained workload. You can see here that on this given configuration, it's driving around 10 megabytes per second, which is not too much. This is a standard ESX host that's attached to external storage, shared storage models. What we're going to do is we're going to vMotion this VM to run on the same hardware that is simultaneously presenting up Isilon storage. In other words, the Isilon nodes can simultaneously do storage and compute. In other words, we have ESX running on the Isilon nodes at the same time as the core Isilon codebase. So as we vMotion this VM, what we're doing is, in effect, we're moving compute closer to storage. This is a case where often it's easier to actually move the compute than it is to move the information if the information set is huge. And after the vMotion is complete, you can see that there's a dramatic tripling in the amount of bandwidth. Now, over time, this could be even greater, and you could drive much larger amounts of bandwidth workloads. Isilon clusters can support up to about 50 gigabytes per second worth of bandwidth. So this is an example of what we can do by bringing storage and compute closer together. This core idea of running VMs natively on the storage array itself is something that we're doing not only with Isilon, but also with Vmax within EMC R&D. So as you can see, the amount of bandwidth has increased, and this is a perfect example of how some workloads will be enhanced by running natively on the storage subsystem itself. Now, the other example are workloads that are more transactional and IOPS-centric, and that's what we're going to examine next. You can see that on our standard vSphere cluster, we've got another VM that's running there. So let's take a look at that one and see what we can do. So if we go down here, this stock trading application is an application that is very, very transactional in nature. And that's something that's a very good fit to run on PCIe-based solid state and flash technologies. So that's something that EMC is developing, codenamed Project Lightning. What we've done here is we've built a Project Lightning vCenter plugin. So if we go and we take a look, you can see that this individual VM and these ESX hosts, and in fact the cluster, we'll start here at the cluster level. When you go to the VSI plugin, and VSI stands for the Virtual Storage Integrator, this is EMC's unified plugin for all of our storage platforms, we've created a Lightning plugin. And this Lightning plugin shows you the latency across a broad set of workloads at the cluster level, at the host level, and really the most important view is at the individual VM level. So you can see latency, you can see the amount of IOPS that we're driving out of the storage targets for those devices, and you can see here that that individual ESX host has got that individual VM on it. Now if we go and we say, let's see what we could do with that, you know, ideally what you'd want to do is you'd want to go in and you'd say, hey, look, let's enable Lightning for this individual virtual machine, which would enable VM level, guest level, and OS level caching, as well as some things that we're developing around caching at the vSphere host layer itself. But it can't be enabled because currently it's not running on a host that has a Lightning adapter. So here what we're going to do is we're going to, in effect, move the storage closer to the compute. What we're going to do is we're going to move the compute to a vSphere host that has a Lightning adapter, and then what we're going to do is we're going to then enable Lightning caching for that individual VM. So you can see now that it's running on a host with the Lightning card in it. We can now then, using that plugin, go in and we can enable it. And what's really cool is the plugin prototype allows you to select a single VM, or you could group select them. But you can see here that we could enable this individual VM, and you can actually do that at either the cluster layer or the host layer or the individual VM layer. So you can see here the graphing shows in all three of the views. This is also something potentially we're going to do for a lot of storage use cases, but that's another discussion for another day. Here what we're going to do is we're going to enable Lightning for this individual VM and keep a close eye on the graph at the bottom. You can see that the latency plummets as the cache utilization for the Lightning card increases. And you can see here it's integrated right into our plugin, so you can disable it if you wanted to. But the other thing that's worth noting is that the array IOPS, the amount of IOs that the array is serving, has dropped dramatically because a significant amount is being absorbed by the Lightning cache on the ESX host itself. And the application IOPS within the guest have gone way, way up. You can also see the cache hit rate and utilization shown there in the prototype of the UI. A powerful demonstration of what we're working on.